Hello all, welcome to Stat Pro. In this video, we will see the second method of interpolation and extrapolation, that is Newton's advancing difference method. In the previous video, we have seen the two conditions of binomial expansion method, which says there should be a common difference in x series and the value of x for which the value of y is to be interpolated must be one of the values of x. The video link of binomial expansion method is given in the description box. We have a disadvantage of binomial expansion method where we cannot find out the value of y which is not in the given x series. To find that missing value, we use Newton's advancing difference method. Just to make it more clear, we will see an example. In this example, x and y values are given. If suppose we want the value of y at x is equal to 30, we go for binomial expansion method. If suppose we want the value of y at x is equal to 32 or 35 or 41 or any value which is not in the given x series, then we go for Newton's advancing difference method. Let us solve a problem on Newton's advancing difference method. The table shows the expectation of life at different ages. Using Newton's forward difference method, interpolate the expectation of life at age 26. Age in years 15, 20, 25, 30 and 35. Expectation of life in years 30, 29, 27, 24 and 20. In this problem, we need to find the value of y at x is equal to 26, which is not in the given x series and is a intermediate value. Therefore, we use Newton's advancing difference method. Let x be independent variable and y be dependent variable, where y takes the values y0, y1, y2, y3 and y4. This is the Newton's advancing difference method formula to find the value of y at x. In this formula, yx is the value of y which is to be found out. Y0 is the value of y at origin, that is 30. The value of x can be found out by using the below formula. X is equal to the value of x to be interpolated, that is 26, which is given in the question, minus the value of x at origin, that is 15, that is x naught. The difference between the two adjoining values of x is 5. So here we can say it is 5, 5, 5 and 5. Now let us substitute the values and find out the value of x. So x is equal to the value of x to be interpolated is 26 minus the value of x at origin is 15 divided by the difference between the two adjoining values of x is 5. After simplification, we get x is equal to 2.2. So x is equal to 2.2. Now we need to find the values of deltas from the formula. Delta is the leading difference. It starts from 1 and ends at n minus 1. That is delta 01, delta 02, so on and so forth, delta 0 n minus 1. Here n is number of known values of y. In this problem, the value of n is equal to 5 because we have 5 known values. We need to find the value of delta 01, delta 02, delta 03 and delta 04 in this problem. That can be done by using leading difference table. We know that x is our independent variable and y is our dependent variable, and y takes the values y0, y1, y2, y3 and y4. So now we have to find out the leading differences. So delta 1 is our first leading difference. So that can be found out by subtracting y1 minus y0. Here y1 is 29 and y0 is 30. So 29 minus 30 is minus 1. Next y2 minus y1, that is 27 minus 29 is minus 2. Y3 minus y2, 24 minus 27 is minus 3. Y4 minus y3, that is 20 minus 24 is minus 4. Similarly, we will find out the remaining values, that is minus 2 minus of minus 1 is minus 1. Minus 3 minus of minus 2 will become minus 1. Minus 4 minus of minus 3 will become minus 1. Minus 1 minus of minus 1 will be 0. Minus 1, again minus of minus 1 will become 0. 0 minus 0 is again 0. In this table, the first value is our delta 0, 1, that is first leading difference. Next, this is our delta 0, 2, that is our second leading difference. Delta 0, 3 is our third leading difference. And delta 0, 4 is our fourth leading difference, which we are going to use in the formula. Let's rewrite our formula, that is yx is equal to y0 plus x into delta 0, 1 plus x into x minus 1 divided by 2 factorial into delta 0, 2 plus x into x minus 1 x minus 2 divided by 3 factorial into delta 0, 3 plus x into x minus 1 x minus 2 x minus 3 divided by 4 factorial into delta 0, 4. Here we need to stop at delta 0, 4 because the number of known values are 5 and our equation should have 5 terms, that is 1, 2, 3, 4 and 5. Now we know all the values. Now let us substitute all the values. So yx is equal to y0 is 30 plus x we have found out, that is 2.2 into delta 0, 1 from table it is minus 1 plus x is again 2.2, x minus 1 is 1.2 divided by 2 factorial into delta 0, 2 again from the table is minus 1 plus x is 2.2, x minus 1 is 1.2, x minus 2 is 0.2 divided by 3 factorial into delta 0, 3 from the table is 0 plus x is 2.2, x minus 1 is 1.2, x minus 2 is 0.2 and x minus 3 is minus 0.8 divided by 4 factorial into delta 0, 4 from the table is 0. After simplification, we get y26 is equal to 26.48. The expectation of life at the age of 26 years is 26.48, which is approximately 27 years. Let us see few more problems on Newton's advancing difference method. Here I'll be telling you how to solve this kind of problems. Here let us see a problem. From the following table, find out the number of workers earning wages below rupees 25,000. Wages and number of workers are given. Wages are 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. Number of workers is 50, 80, 100, 75, 40, and 25. In this problem, they have asked to find the value of y at x is equal to below 25 rupees. In this problem, they have asked to find the value of y at x is equal to below rupees 25, which is not the exact number. That's why we need to prepare the data before applying Newton's formula. Let us prepare the data: wages and number of workers. Let us write the class intervals as below: below 20, below 30, below 40, below 50, below 60, and below 70. Since the class intervals are written as below 20, below 30, and so on, we write the frequencies as less than cumulative frequencies. Less than cumulative frequencies can be written as the first value will be same, that is 50. The next value will be 50 plus 80 is 130. Next value will be 50 plus 80 plus 100, that is 230. Next, 50 plus 80 plus 100 plus 75 is 305. Similarly, 50 plus 80 plus 100 plus 75 plus 40 is 345. And the last value will be 370, where we'll be adding all the numbers. Now our data is ready. We will calculate the value of x and leading differences, and then we'll apply Newton's formula as we did in the previous problem. With this, we are done with Newton's advancing difference method. Thank you.